So I recently tested the Latitude on the Blackmagic Pocket Cinema Camera 4K. And this camera just keeps impressing me. To test the latitude and the dynamic range of the camera, I set up two different tests. The main latitude test, where I under and overexpose an image with a subject, me, to see at what point does the image fall apart and become unusable. I did this test at both ISO 400 and 3200, the two native ISOs of the camera. But before that, I want to look at the overall dynamic range of the camera. How many stops of latitude do we have above and below middle gray? In the manual for the camera, we get a chart of the dynamic range. At the lower base ISO of 400, we have a total of 13.1 stops. 5.5 are above middle gray and 7.6 are allocated below middle gray. At the higher base ISO of 3200, we have a total of 12.3 stops. 5.1 are allocated above middle gray and 7.2 are below. So basically the purpose of this first test is to see how accurate these numbers are. The test is very simple. I place a Greycard in the frame and expose it to middle gray in camera at the native ISO of 400. I made sure the Greycard was properly exposed by using false color, a light meter, as well as bringing it into DaVinci Resolve to check the waveforms. The Greycard was exposed at 38 IRE, which is middle gray for Blackmagic film. Once a neutral baseline exposure was established, it was just a matter of raising and lowering the exposure to see at what point we start to clip and lose information. When testing for highlights and overexposing, I attached a piece of white tape to the Greycard, and when testing shadows and underexposing, I attached a piece of black tape to the Greycard. The reason for doing this is to get a reference of something that is either brighter or darker than middle gray placed in the same light as the Greycard. The white tape will obviously clip before the Greycard, so when the Greycard reaches the same exposure and looks the same as the white tape, we know we have lost detail and clipped the Greycard. So let's dive in and look at that. First we have our neutral exposure. The image is exposed for the Greycard, so you can ignore everything else. If we go up by 1 stop, no issues. Same thing with 2 stops and 3 stops. When we get to 4 stops, we can see that the texture in the white tape is gone. But once again, we're looking at the Greycard here. At this point I started going by increments of thirds instead. And when we get to 5 stops, we start to get close, but we still have detail in the Greycard. At 5 1/3, we start to lose detail, but we still retain something. It isn't completely gone yet. And when we get to 5 2/3, it's all gone, which we can confirm by going up to 6 stops. We didn't lose any more information since it's already gone. So I would say that Blackmagic's claim of 5.5 stops seems pretty accurate. Somewhere between 5 1/3 and 5 2/3 is where we lost all detail, but we did start to clip at around 5 1/3. So if you were to use a spot meter and get a reading of something that is 5 stops over middle gray, you know you're on the edge. But let's look at shadows instead. And this is a bit trickier, because when you're looking at shadows you don't have that definitive point where you go from retaining information and then clipping, like the highlights. Dynamic range and information in the shadows is a lot harder to determine by eye, and to do it properly you need proper equipment that will give you actual numbers. And that's because we're now dealing with noise. The deeper we dig into the shadows, the more noise will be present. And this is where things like signal to noise ratio comes in. If we expose a pixel with a lot of light, we can drown out the noise. We get a high signal to noise ratio and a clean pixel. When we take away more and more light, we get a signal to noise ratio that becomes worse and worse. When the site Cinema 5D does their dynamic range test, they normally use the value of a signal to noise ratio of 2, meaning that the signal is twice as strong as the noise. Many manufacturers do however use the value from a signal to noise ratio of 1, meaning when the signal and the noise reach the same strength, simply because that will give you a more impressive number, while Cinema 5D uses a number that they think is more relatable to the real world and usable dynamic range. Maybe we got a bit off track here, but let's dig into the shadows and see how far we can still see the difference between the black tape and the Greycard. So let's just quickly go through all the way down to 6 stops. At this point we can still clearly see the Greycard and the piece of tape, without boosting the exposure. It's dark, but I can still see it on my monitor, so make sure you're not using your screen on low brightness, and hopefully the YouTube compression doesn't kill all the information. When we get to 7 stops, I can still see the difference. Obviously it's very noisy down here, so this isn't information you're trying to bring back up, but it still holds some detail. Let's boost the exposure a bit using the exposure offset in the raw settings, just to see it a little brighter. Again, the point of this specific test is not to try and see how far we can underexpose and still bring back to normal exposure. Clearly this is very noisy, and this is where it becomes hard to determine the dynamic range in the shadows just by eye, since we can't quantify the noise. This is what it looks like at 7 2/3, so basically 7.6, which is Blackmagic's claim, and side by side to 6 2/3, which has 1 stop more light. So when it comes to shadow latitude, it's hard to give a concrete number. If we keep going down and boost exposure, we can still technically see the difference at 9 stops, but at this point there is more noise than actual image, as well as me having to boost exposure in the raw settings by 5 stops to even see that. So this is not part of the dynamic range. So if the latitude in the shadows is 6.5, 7 or 7.5 stops, it's more a question of where you think it's still usable detail or not. But I think this test has already taken up enough time, so let's move on to the more interesting test, the over and underexposure test, where we try to see how far we can push and pull the exposure of this camera. I did this test at both ISO 400 and 3200, the 2 native ISOs of the camera, and each one of them have been tested for both over and underexposure. I'll show them to you first with the exposure out of camera, and then with the exposure corrected back to neutral. The exposure shift will be done using the exposure setting in the Camera Raw tab of DaVinci Resolve. So if you want to find out how it handles while underexposing for a darker look, keep an eye on the exposure out of camera. If you want to find out how much you can push and pull the image if you accidentally or intentionally over underexpose the camera, then you have the corrected exposure as well. The over and underexposure was achieved with the shutter, since I didn't want the aperture to affect the image. But let's start with the overexposure test of ISO 400 and I'll see you afterwards. my opinion, this camera holds up great. So great in fact, I actually had to reshoot the 5-stop over test, because the first time I did it, I only went up to 4 stops. And just to make sure it was exposed the same way, I tried a control test which was 1 stop less overexposed, and that matched up perfectly with the +4 from the first time around. At 5 stops, the skin is completely blown out, but at 4 stops it still retains basically all of the information, which caught me off guard. I thought it would be blown out by 4 stops, but at 4 stops over we're just on the edge, and I think we would probably start to clip the skin at around 4 1/3 over. Since the Greycard test started to lose information at 5 1/3 over, and my skin should be roughly 1 stop brighter than middle grey. In hindsight, I probably should have gone by thirds here as well. The brightest spot on my face is just on the edge of clipping, but still retaining my skin at 4 stops over, that's very impressive. Let's go to the underexposure test at ISO 400. Or do you think the images become too noisy? I leave that one up to you. Underexposing by 1 stop is more or less the same thing as correctly exposing the image at ISO 800. In fact, since this is RAW, I can even change the ISO to 800 in post. Exposure at +1 in the RAW settings or changing the ISO to 800 basically gives the same result. The same process or thinking can't really be applied to the other ones though, since ISO 1600 for example is a part of the high ISO circuit. Therefore, exposing it at 1600 would not be the same as underexposing ISO 400 by 2 stops and then pushing it in post, since they're using 2 different ISO circuits on the camera. So at this point it's not just metadata, it's actual hardware. Speaking of the second base ISO, let's look at ISO 3200. I did lower the output of my key light for these, so the ratio between the key and the lamp in the background will be different. Therefore the exposure of the background seems brighter in this test. So keep that in mind if you try to compare side by side the ISO 400 to ISO 3200. But let's look at the first overexposure test. If we look at the skin, the image holds up really well all the way up to 3 stops over. The lamp in the background has blown out parts of the nearby wall, but the skin is still intact. When we go up to 4 stops, we have however lost information in the skin. So compared to ISO 400, we have a little bit less latitude in the highlights here, which can be confirmed by Blackmagic's dynamic range charts, 5.5 stops compared to 5.1. And for our last test of the day, the ISO 3200 underexposure test. And again, when it comes to shadows and noise, I'll let you decide what you're comfortable with. 1 stop under is just like the low base, the same as if we would have exposed the image at ISO 6400 in this case. 2 stops under would be the same as feeding the sensor the same amount of light that would be needed to expose the image properly at ISO 12800. But we can't actually change the ISO to ISO 12800 in post. It caps out at 6400. And that makes me think that the Pocket does something else in camera at those extreme ISOs, such as a different gamma curve, some special noise treatment, or something like that. And if you're interested in the ISO performance of the camera in terms of noise and dynamic range, make sure to check out my last video. But once again, when it comes to noise, I'll let you decide what you're comfortable with, but that pretty much wraps it up for this video. Like the video if you liked it, subscribe if you want to see some more, and I'll see you next time.